In the realm of machine learning, there are primarily two main approaches to tackle different kinds of problems. These are supervised learning and unsupervised learning. First, let's understand supervised learning. Supervised learning involves training a model using labeled data. This means that you provide the model with both the input features and the correct output, enabling it to learn the relationship between them. The goal is to enable the model to make predictions on new, unseen data based on the patterns it has learned from the labeled data. Next, unsupervised learning focuses on discovering hidden patterns and structures in unlabeled data. In this approach, the model is given only the input features without any corresponding output labels. The model's task is to identify inherent relationships, clusters, or patterns within the data without any prior knowledge or guidance. Let's explore the key differences between supervised and unsupervised learning methods. Supervised learning requires labeled training data with input-output pairs. The algorithm learns from explicit feedback and corrects predictions. Supervised learning is commonly used for classification and regression tasks. On the other hand, unsupervised learning works with unlabeled data, finding natural patterns without any explicit feedback. This approach discovers hidden structures and relationships in the data and is often used for clustering and dimensionality reduction. In essence, supervised learning thrives on labeled data for prediction, while unsupervised learning explores unlabeled data to uncover hidden insights. Let's see supervised learning in action with a simple classification example, using Python and the scikit-learn library. The code begins by importing the random forest classifier from the sklearn.ensemble module. Then prepare the labeled data by creating input features stored in the variable xtrain, and corresponding labels such as spam and not spam in the variable ytrain. Next, create an instance of the random forest classifier and train the model using the fit method, passing in the input features and labels. Finally, make predictions on new data using the predict method. To summarize, the model receives labeled training data with known outcomes, learns patterns from the input-output pairs, and then makes predictions on new unseen data based on what it has learned. Now, let's look at unsupervised learning in action with a k-means clustering example, using Python and the scikit-learn library. The code starts by importing the k-means module from sklearn.cluster. Prepare the unlabeled data by creating input features stored in the variable x. Next, create an instance of the k-means model, specifying the number of clusters. Here, the number of clusters is 3. Then, fit the model to the data and predict the cluster assignments for each data point using the fit-predict method. Finally, obtain the coordinates of the cluster centers using the cluster_centers_ attribute. K-means clustering automatically groups similar data points together based on their features. The algorithm identifies cluster centers, shown as circles in the figure, and assigns each point to the nearest center. Now let's explore some common use cases for supervised learning. First, email filtering. Supervised learning classifies incoming emails as either spam or legitimate based on content, sender, and other features learned from labeled examples. Second, medical diagnosis. Supervised learning predicts diseases based on patient symptoms, medical history, and test results using validated diagnostic data. Third, product recommendations. Supervised learning suggests products based on user preferences, past purchases, and behavior patterns from historical data. And fourth, price prediction. Supervised learning forecasts prices using historical data, market indicators, and known value correlations from verified transactions. Now let's explore some common use cases for unsupervised learning. First, customer segmentation. Unsupervised learning identifies natural groupings of customers based on purchasing behavior, demographics, and interaction patterns. Second, anomaly detection. Unsupervised learning discovers unusual patterns in data to detect fraud, system failures, or other anomalous events. Third, topic modeling. Unsupervised learning extracts underlying themes and topics from large collections of documents without predefined categories. And fourth, feature learning. Unsupervised learning automatically discovers relevant features and representations from raw data for improved analysis. Choosing the right machine learning approach depends on the nature of the problem and the available data. If you have labeled data for your problem, where each data point is associated with a known outcome or category, you should consider supervised learning techniques. Supervised learning is suitable for tasks such as classification and regression, where the goal is to predict outcomes or categorize data based on learned patterns from labeled examples. On the other hand, if you do not have labeled data and you're working with unlabeled data where the outcomes are unknown, you should consider unsupervised learning techniques. Unsupervised learning is ideal for tasks like clustering and dimensionality reduction, where the goal is to discover hidden patterns, structures, or relationships within the data without any prior knowledge or guidance. The availability and quality of labeled data often determine the most suitable approach for your machine learning task. Let's summarize the key concepts and best practices. Ensure data quality by using clean representative data with appropriate pre-processing and validation. Choose algorithms based on data characteristics and problem requirements for model selection. Use cross-validation and proper metrics to evaluate model performance during validation. Consider model transparency and explainability requirements for interpretability. As a quick reference, supervised learning needs labeled data to make predictions, whereas unsupervised learning needs unlabeled data to discover patterns. Validation is direct in supervised learning but indirect in unsupervised learning. Supervised learning is used for classification, while unsupervised learning is used for clustering. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.